Supply chain security in cloud-native ecosystems involves ensuring the integrity and security of software throughout its lifecycle, from development to deployment. A breach in the supply chain can lead to widespread vulnerabilities. Real-world example: the SolarWinds hack, which involved inserting malicious code into a legitimate software update, underlines the importance of verifying third-party code and using tools like SigStore for artifact signing and transparency logs to safeguard the software supply chain. Image repositories store container images and play a crucial role in deployment pipelines. Securing these repositories involves using private registries for sensitive images, implementing image signing to ensure authenticity, and conducting regular vulnerability scans. For instance, using Docker's Content Trust in Docker Registry ensures images are signed, verifying their source and integrity before deployment. Observability encompasses monitoring, logging, and tracing to provide insights into the health and performance of applications and infrastructure. In a security context, enhanced observability aids in detecting anomalies and potential security incidents. Real-world application: Kubernetes clusters monitored using Prometheus for metrics and Fluent for logging can offer early warning signs of security issues, facilitating swift response. Service meshes like Istio provide a dedicated infrastructure layer for managing service-to-service communication, offering features such as secure service identity, encrypted traffic, and fine-grained access control. A practical use case is employing Istio to automatically encrypt traffic between services, reducing the risk of data interception within the cluster. PKI provides mechanisms for secure electronic transfer of information for network activities such as email, e-commerce, and internet banking, using a set of roles, policies, hardware, software, and procedures needed to create, manage, distribute, use, store, and revoke digital certificates. In Kubernetes, PKI underpins the cluster's security, facilitating secure communication between cluster components and users by managing TLS certificates for encryption and authentication. Connectivity in Kubernetes, including pod-to-pod and external access, requires robust security to prevent unauthorized access and data breaches. Employing network policies to restrict communications between resources, and using TLS for encrypting data in transit are key measures. An example includes restricting pod communications with network policies to only allow necessary connections, minimizing the attack surface. Admission controllers in Kubernetes act as gatekeepers, enforcing policies before objects are admitted into the cluster. They are crucial for security, enabling administrators to define and enforce compliance and security standards.